Here I am at Coyote Path. So the Winnemucca, actually that's, I think, just the corner of Pyramid Lake you can see out there is a shiny bit out there. So that's the Virginia Range behind it. We're sort of looking southwest towards the afternoon sun. There's the road up the valley. You can see there's a light dusting of snow here it's November 11th. But the main point of this stop is that we're here sort of at the southern edge of the Sahwave batholith. And so right here we're standing on the diorite phase, which isn't super widespread, but it's here and there. It varies in color index, but it's basically a quartz diorite. I said diorite, probably more of a quartz diorite. And it doesn't really outcrop very well, but basically it starts becoming metamorphic rock about halfway down the hill. So we're very close to the southern contact of the southern intrusive contact of the Sahwave intrusive suite. Overlying it to the west here, you can see there are various Miocene basalts. And so if we look off to the north, basically, so that entire range we can see across the skyline there is the Sahwave Range, and so that entire range is part of the Sahwave intrusive suite. The northern most part of it is probably 10 kilometers past that farthest mountain, just for sense of scale here. And so right now we're in the Nightingale Range. So the Nightingale Range and the Sahwave Range together, if you look at the little scraps of tertiary rocks, they form a bit of a taco. They've actually been folded up by the normal faulting. So the Nightingale Range has west dipping normal faults on its west side, and the Sahwave Range has east dipping normal faults on its east side. So we can't see those from here, but they're there. And so the middle of that, between those two faults, is sort of curved up into a taco-like shape. And so you can see one outcrop out there. I'll show a close-up picture of tertiary basalt, or some sort of Miocene, I think probably basalt on that hill there. And you can see that's dipping off to the left. And right here in the southern Nightingale Range, they're basically flat lying, but if we get a little bit further north, all of the basalts on the Nightingale Range are dipping generally to the east. So there's definitely a syncline in there. One thing that I've always puzzled a little bit about is why is the Sahwave Range so low relief? Part of that might be because most of that sort of flat moorland surface you see there is just a little bit below the eroded away tertiary inconformity. And so if that was a long-standing inconformity, that could have had been weathering for a very long time, and that might be part of the reason why it's such a low relief surface. I also wonder if maybe the folding of a solid rock like granite into a syncline might make pervasive fracturing that made the granite weather a little bit more. But that's hard to say.